This lesson is about frames of reference and coordinate systems. We'll be talking about what frames of reference are, how coordinate systems work, movement of frames of reference, and different kinds of frames of reference that can be used. Imagine that you want to measure the movement of a bug that you see. It's an interesting, friendly-looking little bug. What would you need to measure his movement? You might need a ruler, right? But you need more. You need to know where you're measuring his movement from. Are you measuring how far he is from you? How far he goes across the ground from some mark? What you need is a frame of reference. If the bug is crawling across a table, the table might be your frame of reference, and you might measure how far the bug moves from the edge of the table. Maybe the bug's crawling across a piece of graph paper. You could use the graph paper as your frame of reference and measure how many squares he moves from the edge. Whatever frame of reference you use, you're going to need some kind of coordinate system. A coordinate system is how we measure the location of an object within a frame of reference. There's many kinds of coordinate systems, like latitude and longitude, used to measure places on the surface of the Earth. There are polar coordinate systems that use degrees. Even a simple number line can be a coordinate system in one dimension. In physics class, we mostly use a two-dimensional coordinate system with an x-axis and a y-axis. Remember that the y-axis normally goes vertically or up and down on the paper, and the x-axis is horizontal or side to side. If we're measuring the movement of objects in the real world, we might use a three-dimensional coordinate system with an x, y, and z axis. Now, our frame of reference, whether it's a graph paper or something else, could be stationary or it could be moving. If it's a piece of graph paper sitting on the table, it's a stationary frame of reference. But if we put the bug and the graph paper inside a car, now the whole frame of reference is moving. We can still make the same measurements either way, though. If we're inside of a moving frame of reference, it may look like objects outside are moving. In this case, the bug sees the trees as if they're moving and he's standing still, because he is in a moving frame of reference. Our whole Earth is actually a moving frame of reference, and we can measure objects in many different frames of reference, including the Earth. We could measure the movement of the car across the surface of the Earth. We could measure the movement of the bug across the graph paper, but whether we're using the graph paper, the distance down the street, or the orbit of the Earth around the sun, we're talking about frames of reference. When you're doing an experiment, you should choose whichever frame of reference is going to be convenient and is going to make sense based on what you're trying to measure. If you did an experiment where you were dropping a bowling ball off the roof of a building, first of all, don't do that. That's dangerous. But if you needed to do it, you could choose a frame of reference that started from the top of the building. Then as the ball fell, it's moving in the negative y direction, and the numbers would get more and more negative as the ball moved towards the ground. Or you could choose a frame of reference from the ground level, where the ball would start at a high number on y, and as it fell, the number would get smaller and smaller. Or you could even choose a frame of reference centered on the ball, where the ball would stay stationary, and you would measure the movement of the building and the ground towards the ball. In this lesson, we had an introduction to frames of reference, which are used to describe the location of objects, and coordinate systems that are used to measure the location of objects within the frame of reference. We reviewed x and y axes, where the x-axis is normally horizontal and the y-axis is usually vertical. We saw that a frame of reference can be stationary or it can be moving. And we saw that objects can be measured in different frames of reference depending on what you need to measure.